Hey everybody, welcome back to the 4.1 notes. In this video, I'm going to go over solving quadratic equations when a is not equal to 1. So what I mean by that is you're going to have a number in front of the x squared. In the previous video, there was no number in front of the x squared when we factored it, so the a value was 1. So before I get started, I'd like to just do a quick little recall problem. How do you factor a term when the a value is 1? Well, all you got to do is look at the last number and look at the middle number. So you got to think, what are the factors of positive 56 that add up to negative 15? And that's going to be 8 and 7. And you got to make them both negative because two negatives can multiply to get a positive number, and then they'll add together for a negative number. So I'll take the negative 8 and the negative 7, and I'll write my answer, or I'll write my equation, I should say, in factored form. So I turn it into x minus 8 times x minus 7. And then from there, you'd get your two solutions of 8 and 7. How do you know that? Well, you just take whatever's in the parentheses and you set it equal to 0. So x minus 8 equals 0, x equals 7 equals 0. So 8 minus 8 equals 0, and 7 minus 7 equals 0, giving me my two solutions of 8 and 7. So the process will be a little bit longer if there's a number in front of the x squared, so if a is not equal to 1. So for starters, if you're given a problem like this, you'll want to get everything over on one side. So for this problem, all it took was just adding the 12 over. You'll want to keep it separate from these other two terms because this 12 is not a like term. It doesn't have any letters with it. So I have 2x squared minus 11x plus 12. And so in the previous example, I looked at the factors of the last number that added up to the middle number. Well, when there's a number in front of the x squared, you're going to take that number and you're going to multiply it to the back number. So this bottom number will be the a times c number. So what's 2 times 12? That's 24. And then that middle number can stay the same. So what you're trying to do is you're trying to think of what are the factors of 24 that add to get negative 11. And in this case, that's going to be negative 8 and negative 3. And so we'll turn that into our factored form as x minus 8 and x minus 3. The thing is, this problem is not completely factored yet. Because you took this 2 and you multiplied it to the back, that was just to help you determine what these two factors are right here. So basically what we need to do now is kind of undo that step. So if I took 2 and I multiplied it to the back, I'm going to undo it by dividing it out from the factors I just got. So I'm going to take this x minus 8 and I'm going to put a divide by 2. I'm going to take the x minus 3 and put a divide by 2. And so the nice thing that happens here is if the fraction simplifies or makes a whole number, you're going to want to do that. So like 8 over 2 is going to make 4. So this is just going to turn into x minus 4. And so if it stays a fraction, 3 over 2, you're going to want to take that number and you're going to want to swing it up front. And so that's going to turn into 2x minus 3 equals 0. So this right here is going to be the fully factored form of 2x squared minus 11x plus 12. So if you ever want to check your work, please graph it. What you'll want to do is you'll want to type this in. Ignore the equals 0 because it's not going to give you the appearance of the graph if you leave in the equals 0. So just type in 2x squared minus 11x plus 12. And on the other line of the graph, you'll just want to type in the x minus 4 times 2x minus 3. Again, you can ignore the equals 0. Just type it in like that. And the graph should overlap. If they don't overlap, if you see two separate parabolas, then you made a mistake somewhere in your work. So here's a screen grab from Desmos. You can see here I have two equations typed in, and it's really hard to see that these graphs are overlapping. You can see that it's not like perfectly purple. It's a little darker because it's overlapping with the green color. So I guess you'll just have to take my word for it that these graphs are overlapping. But yeah, that's the point I'm trying to make here. And then while you're looking at Desmos, you can tap where the x-intercepts are to get your answers, which we're going to do by hand in just a moment here. So solving these will be the same thing as you did before when when a was 1. You'll take whatever's written in the parentheses and you'll set it equal to 0. The only thing is, whenever there's a number in front of the x, you can't just flip the sign. I can't just say the answer is 3 here. And not every kid is great at solving problems, even though this is just a two-step problem. Plus 3 over, divide by 2, you get 3 over 2. So I just tell them, look at the previous step. When you divided out that front number, if you flip the signs on this step, you'll get your answer. What's the opposite of negative 8 over 2? Positive 8 over 2, or positive 4. So that's the opposite of this one right here. Positive 4 minus 4 is 0. So I can say x equals 4 from this. But like I said, the answer shows up in the previous step as well. So if you didn't know to add 3 over and then divide by 2 to get x equals 3 over 2, look at this. What's the opposite of negative 3 over 2? Positive 3 over 2. So that's kind of why I like referring to this previous step, because it is kind of a shortcut way of, not having to show as much work. As long as you have it set up like this, you can just pretty much say x equals 3 over 2 just by looking at the above equation. So these are my two answers, x equals 3 over 2. I always encourage you to check your work by graphing. So here's a screen grab from the same graph from earlier, just with the x-intercepts labeled. You see I got 1.5, which is what 3 over 2 is in decimal form, and then 4 comma 0 is the other answer. So before I do any more examples, I wanted to go back to this first one that I did when a was 1 to relate back the process we just did. What I did was I took that number, that front number, and I multiplied it to the back number. So even if you did this when a was 1, you'd still get the same answer. If I did 1 times 56, that's 56, right? And then if I took the factors that I got and I divided them by 1, you'd still get the same answers. Anything divided by 1 is itself, so I'd still get x equals 8 and x equals 7. Even if you took the 1s and you swung them up front, like I said, you only have to swing the number up front if it stays a fraction, but I'm just saying, even if you took the 1s and swung them up front, then you'd have 1x's, and that's still not changing the values of anything. So that's why when a equals 1, you don't have to do this whole front number times the back number and then divide it out kind of thing, because if you're multiplying or dividing by 1, you're not changing the value of anything. So I hope that makes sense. So for this next example, I don't have everything in standard form. So what you'll want to do is, add or subtract all terms over to one side. It doesn't really matter if things are on the left-hand side or the right-hand side of the equal sign. But what I tell kids is, as long as that ax squared value is positive, you want things to go on that side. So if this is positive like it is right now, I'll want to move these two terms over to this side. If this were negative, I'd want to move everything over to the right-hand side of the equation, because the problems are just way easier to do when that a value is positive. So what I did was I added 7x to the other side, and I put it under the 8x because those are the like terms. They just have a regular x with no exponents. And then I minus the 8 over to the 26 because those are both my constant terms. So 26 minus 8 is 18, giving me the equation in standard form now of 3x squared plus 15x plus 18 equal to 0. What I'll do next is I'll take that 3, I'll multiply it to the 18. 3 times 18 is 54. So I'll ask myself, what are the factors of 54 that add up to 15? So 54 has a handful of factors. So again, if you ever get stumped, just make a list of the factors of 54. But in this case, it's just going to be 9 and 6. 9 plus 6 is 15. 9 times 6 is 54. So I'll write x plus 9 times x plus 6 equals 0. And so remember, this is not fully factored yet because I need to now divide out that 3 that I multiplied to the back just a step earlier. So you'll notice that both of these divide perfectly x plus 9 over 3 turns into x plus 3, and x plus 6 over 3 turns into x plus 2. And then don't forget your equals 0. So what happened was we had a greatest common factor. If you look at your standard form equation, 3x squared plus 15x plus 18, all those numbers are divisible by 3. So when you have a greatest common factor and you're solving it like this, when you get to this step right here, it's going to perfectly divide. So in the event that that happens, all you do is take that greatest common factor and you just put it on the outside right there. So now I still have my 3, because if you think about it, if you were to FOIL this back out, you'd do x times x, x times 2, 3 times x, 3 times 2. You'd never get a 3x squared. But when you just throw a 3 in front, you will now have a 3x squared. And then you'll also get back to these values here. So if I lost you right there, then I encourage you to look at the graph. Maybe that'll help. When you type in the original and standard form, you get this graph. And then when you type in the factored form with the greatest common factor of 3 out in front, the graph will overlap. So this kind of purplish looking graph right here are these two overlapping. And then if you've forgotten the 3, you'd see they clearly make a different graph. Now, the positive thing here is that they have the same x-intercepts. So that's good. So if you forget to write that greatest common factor out in front, you're still going to end up getting the correct answer when you finish solving it. But you will have gotten that factoring portion of the question wrong, or a little bit wrong. So it all kind of depends on what your teacher's looking for. For me, I want the kids to be able to get the factoring done completely correct and get their solving correct. So I do want to see the 3 in front. If there's a greatest common factor, I want to see that number out in front. But, so this is kind of a special case because this doesn't happen often, but sometimes you are given a problem with the greatest common factor in it. Back to solving this, just take whatever's in the parentheses, set it equal to 0, so you get x equals -3 and x equals -2. You don't have to worry about this 3. It's not going to affect the solving because it doesn't have an x with it. Every time you see an x, you want to set that equal to 0 and solve. So if I look at that same graph from earlier, you'll notice that they had the x-intercepts at -3 and -2. So always check your work by graphing. In this last example here, you'll notice that it's already in standard form because it equals 0. So you can just jump right in and take that front number and multiply it to the back number. So you have 4 times -3, that's going to give you -12. Definitely pay attention to the sign that's by the numbers. It's a -12 and not a +12. And so you got no middle number, but you have an x, which means you technically do have a middle number. It's just not blatantly there. What I'm trying to get at is your b value is 1. So I'm going to think of the factors of -12 that add up to 1. And so people always get stumped when it adds up to 1. 12 is 4 times 3, and 4 minus 3 is 1. And 4 times a -3 is -12. Because we had a negative factor here and a positive factor there, that means one of the factors will be positive and one of them will be negative. The smaller one will be negative because we had a positive b value. So I'll take those two factors and I'll write x plus 4 times x minus 3 for my intermediate step. And then I'll take that 4 that I had multiplied to the back and now I'll divide it out. And so x plus 4 over 4, well, 4 divided by 4 makes 1, so that turns into x plus 1. And then x minus 3 over 4, that doesn't simplify or anything, so you just take that 4 and you swing it up front. So you have 4x minus 3 equals to 0. And so you take these two and set them equal to 0. X plus 1 equals 0, and 4x minus 3 equals 0. So on this one, you get x equals -1. On this one, you're going to get x equals 3 over 4. Again, how did I get that so quickly? Well, you can kind of do these two-step problems in your head. Add 3 to the other side, and you get 4x equals 3. So divide both sides by 4, and you get x equals 3 over 4. But like I said before, the easier thing to do is just look at the step above and you had x minus 3 over 4, and flip that sign, that'd be a positive 3 over 4. So those are my two solutions of negative 1 and 3 over 4. And so what do you think I'm going to do now? I'm going to show you the graph. Here's the original, the standard form equation. Again, you'd never have to type in the equals 0. And then here's my factored form, the fully factored form, after you divided out the 4 or whatever. And then I labeled my x-intercepts, and I got negative 1 and 0.75. That's 3 over 4. So the Desmos is never going to show you the answer in fraction form. But if you're, not comfortable with fractions, you can always type this into a calculator and it'll output 0.75. So yeah, that's going to wrap it up for these examples. Thank you for watching these notes. Hope you learned something, and goodbye.